Maybe we could open the floor just very briefly to any sort of comments or concerns. How did you like that? Our program is done. Now let's turn to the most important part of it, the audience. Meredith, perhaps you could join me here. Instead of leading a section, Meredith has been dutifully live tweeting so that the internets know what is going on. Maybe we will be streaming the next workshop.
Hopefully we could. I'd like
Hopefully we could. So, feedback. Yes?
I mentioned earlier, in listening to several of the talks, it occurred to me that a useful research project might be to develop a tool to reverse engineer the grammars from implemented parsers. So look at the binary and use some combination of fuzzing by feeding input to a path analysis to see where the code is actually going. Reconstruct the grammar, which you could then pull out, re-implement, and replace legacy parsers with better engineered parsers. For some it would be easy, for some it would be impossible, but it seems like there might be an interesting research project there for some people.
Yeah, I mean, we saw, some work earlier today, like in extracting session languages from binaries, and also in going forward from, okay, we have a state machine, we have the message formats, Prashant's work, we can, we generate the protocol from that. So, yeah.
I mean, in some cases, you might not even have the documentation anymore, or even know what, you just have some code, you don't even really, it's parsing, you have really no idea what the language is.
Right. Long?
You're absolutely right that varies very much. I've reverse engineered a few applications with parse inputs, and some of them you actually see the author coding a state machine and a table inside the binary, and all I do is take that out. And others, it's just a bunch of parsing routines. And I guess it's not really even a context-free. It's probably context-sensitive language.
Jacob?
So we've been focused on kind of the cutting edge research du jour. We step back, where do you see LangSec in 10 years, and what do you think needs to happen to get there?
I'm actually so focused right now on the what needs to happen to get there that where there is actually a little harder to describe. I mean, there was so much work this year on session languages, on the state machines of protocols. Perry and I were talking in whispers basically about, is it time to go to the IETF and basically require not only an ABF grammar for message formats, but also a both human readable and machine readable state machine description for acceptance on an RFC.
It would not even have precedent. The IETF has already made that a formal recommendation. I don't have the RFC number on me, but
I mean, 5234 is the ABNF definition, and it's certainly recommended. But I'm thinking can we make a push for honest-to-God acceptance criteria?
Let me supply yet another item. Last year, out of this roundtable came the idea to formulate CWEs that would be useful to code auditors. Falcon, you can wave. We presented a paper on this at the first IEEE SecDev conference, and it received some interest. And of course, now we have to forge the language and persuade the CWE people to take it. But we have broken ground on that work. And we want LangSec to be a part of every code audit. So that's a pretty good goal for 10 years. And then, of course, looking more ambitiously, we want the parsers that are written in 10 years to be written in parser combinators.
And in memory-safe languages.
And in memory-safe languages.
And in type-checkable languages, and so on and so forth.
More.
All these ratchets that Perry's been talking about. I mean, you know, these need to become part of build systems. Tooling needs to exist to support these.
I
And
think a big aspect though is ad hoc languages. Right? I think that's a really dangerous area that needs to be addressed.
do you want to elaborate on that some?
Well,
By, like, what do you mean by ad hoc languages
so
exactly
I
here?
mean that all of these JavaScript apps that people are writing, they have their own little JSON language to talk to the server. I mean, we talk about that with
I mean, in a way here you're talking about DSLs, right? I mean, which
yeah, exactly. But
people are going to need to learn good DSL design patterns.
exactly.
Yes.
And that's what I'm getting at, right? Is that there are so many languages out there that never touch on RFC. They never get close to being RFC status, and yet they are extraordinarily prevalent, and we need to affect them too.
That's a good point.
Okay, personally, I would like to sort of us to get off the topic of parsing. Basically, parsing is parsing, but I mean, I remember in 1996 there were some nice papers on the spin operating system which used language features to implement extensibility in an operating system kernel, and a nice paper about what features you need in the language to do what it is doing, and that sort of thing is pretty nice, using language for much more interesting purposes. And I'm sorry that we seem to have given up on things like that.
I don't know, have we?
We haven't really, but of course, it's easier to concentrate on that very code that comes into contact with untrusted inputs and gets exploited. You know, this is where most of your weird machines are. But as you recall, our starting paper, the formal applications, the security applications of formal language theory, it also branched out in the languages of events passing through a reference monitor, and similar concerns of systems design.
I mean, we didn't have any ELFBAC related work this year, but I mean, a big part of the whole point of ELFBAC is that loaders have languages too.
Right. And of course, not everything that people think of as parsing is parsing, right? And not everything that people don't think of as parsing isn't actually parsing. So your loader is definitely a parser. Your driver is very often a parser. As we have just seen, there are. Well, okay. So let me give you a specific example. What about the Intel management engine, which turned out to contain a parser?
And which you can apparently like DOS by like pulling a particular audio input on the dot connector high, which I find hilarious. You can shut off the web server by DOSing the entire management engine.
Yeah, but even the deal with admitting an empty credential, because parsing in C, what could go wrong?
Parsers are important. Aim higher.
Indeed.
Yeah, I mean, I think aiming higher is what we're trying to do, but we have to have the shoulders of giants to stand on in order to do that.
Another 10-year goal is that every data protocol that is being proposed to some sort of a major application, such as vehicle-to-vehicle communications, vehicle-to-infrastructure communications, any other critical infrastructure, gets its data reviewed for complexity and for the gotchas that will make interacting with that protocol a very, very painful security experience for all. You lose the security game at the point when you've designed an overly complex data format. This is where your parser differentials nest. This is where they will come to roost.
Which parts of these things can we automate? So talking of those tricks you just said, so putting the human out of the way, right? So automating all the things and throwing it at developers. So which things come to your mind?
Where do I start? I mean, if we go, I mean, if we just go chronologically from yesterday, right? Like incorporating fuzz testing into, you know, into build tooling, you know, like Rust has done. Automate generation of both parsers and unparsers. Automate generation of state machine languages. I mean, if we have if we have a machine readable spec to do it from.
And not necessarily automate, but make it easy to express grammars in the language. If you think of it, it's a shame that your most typical element of your most typical network protocol, a sequence of variable length options or headers, has no standard way of being expressible in C and requires a stepping pointer to go through the goddamn thing and dereferencing that pointer and casting that pointer, where you can't be declarative about a structure, an input structure that's this simple.
Meanwhile, in Erlang, you know, that kind of stuff is first-class language operations.
Right. So this is not strictly speaking automation, but if this is made a part of the language by way of the language design, by way of the library, we'll be much better off.
Yeah, I mean, automation you need when you can't express things cleanly in the language itself. I mean, this is why Java has a giant code smell all over it. Because it's not just like, you know, parsers for, you know, like look at JAX-B, right? Like look at pretty much anything that, you know, that deals with EJB, right? It's all like code gets generated from XML specification type crap, you know, because the language doesn't provide good support for, you know, for ways to configure these things.
Can I add something on?
Absolutely.
I feel like what we really, if we have kind of a platform-independent way to specify protocols, which obviously we have some of in the verification, but if we could sort of build a standard and then build tool support it, where it sort of says, you know, oh, you want to implement a protocol, well, what's your finite state machine? What are your, you know, say regular expressions for your messages? And of course, it wouldn't force anybody to use that, but if that, you know, it was
That's what I'm aiming towards. Yeah, that's the kind of tooling I want to see. Yeah, I mean, ultimately, it would be really awesome to be able to just like rip two appendices out of your, you know, out of your RFC and just feed them to a couple of code generators, and you're done.
Yeah, and if we could get that
Possibly
made,
removing, you know, page numbers in Word or something, but nothing significant.
but if that can become sort of if you can get people to start thinking of that as the default way to build a protocol,
Right.
and you don't even have to say, go analyze your protocol and prove this is regular, because you just have this thing sitting there saying, give me your regular expressions, give me your
Right.
SSAs.
And that is the goal. That is definitely the goal.
As is my tradition, I'll be bold here again. I'm really encouraged by this system that we have, all of the talks that I've seen here and elsewhere, about writing the parser in a memory-safe language and then simply linking that into an existing application. That makes a very good ratchet function, but I wonder if we might be able to leverage the power that languages have in causing people to adopt the most Pythonic way, or the most rusty way, if you will, of doing a thing, and actually get some language developer to include this in the standard library of the next version of their language. I know that, for example, at SecDev, some people who were working currently on the specification of Java 8 at the time were very interested in the work that we were doing.
And Scala at least used to have parser combinators in the standard library. I mean, I don't know. What do you guys? What are you guys' feeling about the Rust standard library? Like, do you think NOM could be folded in?
Probably not, because like it uses macros and it's a contentious subject.
I see.
Because people think they're ugly.
People think they're what?
Ugly.
Macros.
Yeah. Basically, there's a new feature in NOM that should appear this year that will make it easier to write parser combinators like NOM but without macros. And I'll probably switch to that at some point.
Okay, so like it's something that we could work towards. I mean, because I was standing here thinking, God, am I going to have to friggin' port Hammer to Rust and do all all of the LLVM JIT crap like in Rust? I'm sure we could. I'm not sure I'd want to.
Explicitly getting NOM into the standard library is undesirable. Like the language team is going out of their way to try and get things out of it, because if it's in the standard library, you're tied to a 6-week release cycle, right? And if you bump into bugs, like there's very little you can do about it apart from a point release. which is one of the reasons that like the libc crate, for example, like lives in the compiler, and the compiler comes with one because kind of need libc to compile programs. But if you want to consume libc, it's a compiler. If you try to use the compiler's one, you have to fetch it from Kaggle, right? Because then you can actually get an up-to-date crate, and you're not like attached to the compiler's release cycle.
Okay.
So like, broadly speaking, when package management sucked, like getting things into the standard library was good because then you could use it. But at this point, like now that we have a coherent package management story, like I don't think it's intrinsically good to bundle it with the compiler.
So if that's the state of facts on the ground in the Rust world, how do we work with that?
I feel as though if it were formally verified, this wouldn't be quite as big of a deal, but that might be too ambitious.
If non were formally verified, you mean?
Or am I just tripping over myself? It isn't already.
Well, there isn't a formal semantics for
That
Rust.
would be workable. There's an intermediate representation of Rust that's a bit above the LVN1, and that's being worked to translate that to the lean theorem cover. So, and since most of them is just array access, there's definitely something that should be done.
Well, you really want to do the verification against the source language. Otherwise,
It's
it would
not the source, is just the last thing between send to LLVM. So it's already pretty low level, but it still has type information.
Rust really lacks formal verification tools at the
Well,
moment.
because there isn't a formal semantics for Rust yet.
Yes.
A formal semantics for Rust would be something for a heroic piece of work.
I should make a logistical announcement. If you have a car parked with a hotel, apparently at 6, some sort of a timer rolls over, and they might charge you a lot extra. So just
If you need to move your
if you
car,
need
now
to
is
move
probably
your car,
the time.
yes.
I have to do that. So I would make
Okay, do it, Pete.
I think that if integrating something like non with something like Rust, making part of the standard library, is going to upset people because they're going to say things like, "We've already got read and write. And if I write programs that do I/O, I'm just going to use those, and you're not going to bother using them." I think the way we win here is replace read and write with non.
I don't know.
Because whenever a program does I/O, it's parsing, implicitly or explicitly. So the way we win is we make it so that whenever whenever input is consumed, it's parsed with something like that. I think that's the only way.
I would agree with that. Just looking at, I mean, even stuff in C with doing mem copy and or reading one buffer into another. There's the old way of doing that, which I can't remember the function name all of a sudden. Stir copy or stir copy. And when you give people the option to do both, some number of people are still going to use the old one because they say, this one's good enough for me, I've been using it, it works. I think the only way to win is to let everybody only use the functions that they know how to use, and on the back end, replace it so it's always doing the same thing.
Yes.
Something we had talked about is, could you build Hammer in such a way that you could basically provide a grammar and then you could poison, for example, scanf? That you could only use scanf when providing a grammar that then would automatically generate, kind of like what Nail does, going from a data specification. So the only way you can take input rather than say cin or scanf is to go through.
Well, you can do that. I mean, if you're running a project, you can simply make it a requirement that you not use particular calls. But it's difficult to impose this on the world of large calls.
Well, I mean, there's always going to be a human process,
But
right?
it's not part of an individual project to even use tools to forbid the use of particular comments. It's just the issues are probably elsewhere. If people don't want to, if people don't want to do the correct thing, don't know what the correct thing is, that's the worst problem.
so heavy-handed with this. It is that if what we've seen with TLS implementations is any guide, we'll just see a litany of posts on Stack Overflow saying, why yes, just tell it that its grammar is ** and it will be regular and everything will be fine.
Yes, that will be a fabulous Stack Overflow.
I think that it would be neat to make it very easy and integrate parser combinator with the language so that the syntax is familiar to developers, shove it in their face, and then tell them that they don't need to use walking pointers anymore and see if they adopt it.
I hate every single character of the code that has walking pointers. I had to write some recently, and I felt unclean through the whole process.
I kind of feel like a question that might help us like explore the issue you just raised a little more would be, why don't more people use Erlang?
Because its syntax is unfamiliar and its standard library is unknown to people and they weren't taught it.
But I mean, if you're talking about like essentially moving a new syntax for like CN or FRead into the standard library of a thing, like that's a bridge you have to cross somehow.
Well, people learned how to use standard library containers and override objects in C++.
So I think Lee's talk had a very relevant piece on this, right? How do you throw essentially a functional language piece of control code over to the people who actually do write the control code?
Yeah, I did find it really fascinating that it was basically C-type signatures and Haskell bodies. That was rad.
Yeah, so this is what we have to do. I mean, the answer why people are not using a language that they don't know for a code base that they do know is kind of obvious. They don't know it, they know the code base, they're scared. Ezekiel, you had a...
Yeah, so this is maybe a bit of a tangent, but coming from the perspective of not being a security person, caring about this stuff, and having experience doing web applications, I wonder, since like I've got to do parsing in the browser, what would I do? Like, because if I want to do parsing on the back end, well, that's probably a different language. If I parse in the front end, that's JavaScript. And now I have to have two different parsers, so I have to have a parser differential.
I did get Hammer to compile under Emscripten. I just have no idea what to do with the results I got.
That's Emscripten gives you like a virtual C environment that doesn't really talk to the rest of the JavaScript.
Okay, so basically, like, it's not useful to Emscript in a library?
Probably not. But on the other hand, building a parser combinator library for JavaScript shouldn't be too hard.
Oh, yeah, no, I mean, like, the syntax that we used for the combinators in Hammer was actually inspired by a JavaScript parser combinator library.
But then if you've got a parser combinator in JavaScript, and you've got a different parser combinator, say you're using Ruby on the back end, do you have the risk of a parser differential now?
This gets us back to the question of formal semantics, because the body, right, of each combinator, of course, would need to satisfy the same preconditions, invariants, and postconditions in order for the behavior to and also the same side effects in order for the behavior to be identical.
I'd say as a practical matter, if you're going to have to write this anyway, this is a better way than the alternative ways to write it. And yeah, not having the same code base on both sides is risky, but like using a shotgun parser on both sides is worse.
Certainly.
Well, there is also the aspect of if your language is too complex, then you're doomed to parser differentials.
But I mean, I have been talking with Prashant and Mike about getting some formal verification into Hammer, and we're like evaluating tools for that. And maybe we should talk with you about that some, Perry. I mean, just because to start with, there's some underlying data structures that that we can prove some invariance about.
It might be a substantial undertaking, but one possibility would be to have one canonical representation for the grammars, and then have bidirectional transformation. So you have one that goes into C, one that goes into Java, one that goes into JavaScript, one that goes into Erlang, one that goes into Haskell.
Isn't that
And
similar?
then, but the point is, by going in both directions, if somebody writes it in JavaScript, because that's what they're familiar with, they can automatically translate that JavaScript code into the standard one, and from there generate the Java on the back end or whatever, and have exactly the same grammar.
Is there a formal semantics of JavaScript?
No. I'm saying you have
If you answer this question.
you have a stylized script. So in other words, the user writing JavaScript in a very canonical way, it's going to be familiar to them because they know JavaScript, writes out this grammar. As long as they follow this template, essentially, then some mechanical tool could take that and lift it into the...
The tricky bit is that the tool needs to generate equivalent code
So
between...
here is the answer to your question, but you're not going, but although the answer is interesting, it's not what you want to hear.
Okay.
So there is, in fact, a formal semantics for JavaScript built as in like K, which is a really cool system. And it's an executable formal semantics, and it passes the entire ECMAScript 5.1 conformance test suite. But here's the problem. No other JavaScript implementation even passes 90% of the suite. So JavaScript has this problem of many different of language version skew. So the formal semantics that someone has done for JavaScript apply to exactly none of the versions of JavaScript that actually exist in the field.
So every JavaScript implementation is terrible. Great.
Let's be clear, what I'm suggesting is much simpler.
No, I understand.
You don't need a formal semantics for the entire language. You just need to be able to recognize this canonical script that defines the grammar.
Right. Yeah. No, I get where you're going on the front end. I'm just worried about equivalence on the back end.
Isn't that similar to just an extended protocol buffer, where you have some neutral language that describes the format of data, and then it will automatically generate parsers?
But then that's another language. In other words,
Yeah.
the point is, you have lower the impedance by letting people phrase it in the language they're familiar with.
Yeah.
If you're in C, you write it with C structs. If you're in Lisp, you use whatever. You know, every language would have its own way of expressing it. It would seem natural to that program.
Same, right?
Yeah, essentially
Yeah.
the same. It should be very trivial to map from one to the other.
Since you mentioned protocol buffers are actually exemplary in that what they actually implement is a very simple and minimal context-free grammar. If you're writing a protocol buffers implementation, then you are forced by this API to not create anything more complex than a context-free language. Of course, you can absolutely screw this up by creating or implying dependencies between the objects that you extract. And you can add all kinds of context sensitivity to your resulting language. But pure protocol buffers where you do not create any or imply any dependencies between what you unpack is in fact context-free. And it's that language of designing your data packaging that could be translated to other languages, because it's intuitive. I mean, essentially it's simple productions, each production being regular.
So then should we stick with protobuf?
I asked this question. I asked these questions of Googlers, who of course see quite a large code base in protobufs, and people do create dependencies between objects, completely breaking the nice property of protobufs. And so yes, and this is of course where fuzzers have a field day.
Just for the syntax, so for the idea of having one description of the grammar. I mean, what you're describing, these interdependencies, one has to figure out in either way.
Protobufs are essentially, the protobuf API, you can look at it as essentially a way of descriptively writing down a grammar as code. This is important. I mean, if it looks like a grammar, well, it is a grammar in some sense. It is a grammar in the most important sense.
You need a front end for Hammer getting this in there and for Nom getting this in there?
Well, I mean, both Nom and Hammer have their own ways of describing a grammar via parser combinators. But yes, this would be very simple parser combinators.
I mean, I think you could write a grammar in either Nom or Hammer for the protobuf wire format, for instance.
Yeah, you totally could.
What does that get you over using their
I'm not sure.
Well, so the question is where it's getting them, and it's apparently saving them quite a bit of development effort. Should this approach be applied elsewhere, it should save other people quite a number of development hours.
I mean, the problem I see though is like vendors and vendor consortia in particular tend to not want to write protocols that are simple enough to be described in the form of protobufs. And some of that is competition from each vendor trying to get their special feature into the into the control system spec or whatever, but it ends up just piling epicycles on top of epicycles, and so you end up with long distance data dependencies and stuff.
Oh yes, here is another 10-year goal. Try to instill in industries that handle critical infrastructure, such as energy, the idea that designing protocols by committee, and that the protocol is somehow a vessel for accommodating everyone's features. And this is the nice thing to do because you're creating a consensus. You're being nice to all of the members of the consortium. This is exactly not the nice thing to do.
And this is like an actually hard game theory problem, right? Because we're going to have to fight human nature here, and that's never a good idea. But I kind of don't see a way around it.
But this is the very opposite of nice, because you're dooming everyone to a hell of insecurity for, who knows, decades. Of course, your typical piece of infrastructure equipment is supposed to serve 20 years, at least.
But, where's the liability, right? If toll fraud was a big deal to the analog cell phone operators because somebody had to pay for that.
Well, the losses are more evenly distributed. And
commoditization of loss.
I wonder if Cyber ITL might be some people that would be interested in some proofs of maybe the follow-on to the same type of work that needs to be done to push the CWE endgame here. If we can again find some concise list of this is the extent to which that pattern that Meredith is describing increases your risk, it might be a good lever to push on to end it, or at least discourage it.
I'm not sure how linearizable that is, but it's worth exploring. Yes, absolutely. I mean, I suspect it will probably be more qualitative than quantitative, but
there has to come a year when protocols as just a repository of everyone's desirable features just stop being that, when this trend is reversed, when the fight is for getting the least amount of fields in the protocol. And this is seen as the nice thing to do. That, in fact, is my personal program for talking to power industry in a couple of weeks.
That if you want an extra feature of a language, you cough up $100,000, and that goes to a security team that's dealing with all the issues that you created.
The cost of a length field traditionally has been quite high. The cost of a variable width structure is quite high. I mean, look at.
Well, I mean, hell, DNP3 literally had $1 billion mistake in the spec. There was that zero length string resolved to a null pointer.
I'll give you one more. IPv4 options, which now you would not really find in the wild, because it turned out that they were just trouble. And then, of course, IPv6 extension headers with their chains are costing people a lot. I've heard from some operators that they're dropping 40% of all incoming packets of a certain kind in IPv6 on the floor.
Who was
So-
I having a conversation with about insurance earlier today? May have been you. I think it was actually somebody else, but maybe that person is still here.
I was having a conversation with someone about insurance. It actually was not me.
It wasn't me, but I was thinking that this thing that you're addressing right now is something that I, in my penetration testing consulting work, have taken to calling the premature extensibility anti-pattern, the twin of the premature optimization anti-pattern. This is the same place from which we get ubiquitous reflection in Java, frankly. It's just this push that people have to ensure forwards compatibility and extensibility, even though they don't yet know what they think they're going to build. Almost none of these hooks ever get used, and if you look through old RFCs, you'll see a literal graveyard of extensibility features that were never used in reserved fields.
Some statistics on how close to none that is would be useful if you could start keeping track.
Yes, I am very busy, but if somebody wants it.
Well,
The IPv6 flow label is a past study in this, but there are all sorts of them. I mean, the thing is though that most of them are benign because they're fixed length fields that no one ever uses, and so you can simply ignore them. And the problem becomes when things become pricing nightmares. I'm actually reminded of something, which was that when the time came to decide whether IPv6 would get the same Ethernet packet type, because there is a field in the v4 format that has the IP version number in it. It was decided that no, you could not use the IP version number to distinguish different types of IP, because all of the older versions of the thing probably didn't know how to price it or deal with any other value in that field, and it was too dangerous. So most of the time when people actually do things like this and leave them fallow too long, they can't be used anyway, even if you do come up with a use, because there's too much fear that code in the field will explode when it gets confronted with any different value in the field than it's seen traditionally.
No, that's right. And really, the flip side of that same anti-pattern is that it is an instant parser differential when the next version is released.
we did make an attempt to start speaking the language of patterns and anti-patterns. Our SegDev paper was about anti-patterns. Our login article in the past issue was about how we can represent recognizers and unparsers as design patterns familiar to people who actually do design patterns.
It is the interpreter pattern, literally. I mean, there's an entire chapter on this in Gang of 4.
We're coming up on the end of our time.
Oh, are we turning into a pumpkin? Okay.
We could go on, but it's been a long day.
We can also do the traditional. Everyone goes out drinking at what is that place called? Yes, St. Peter's Square Market.
Yep. Could we have the last slide? I think I remember which button to press.
But nothing is projecting.
But nothing is projecting.
I could throw out one more quick idea while you're waiting for that. Seems like a really low hurdle that could be put into the specifications as you join up RFCs or IETF would be that anything that goes into the definition of a language should be formally and concisely specified, but for some definition of formal and concise. Because it drives me crazy when I'm looking at a specification and you have to read 4 paragraphs of English to understand the exception to or the linkage.
Right, because they could do it in just a couple of lines of ABNF, exactly.
Yeah.
And if you can't do it, then there's something wrong. If you need 4 paragraphs of English to explain what you're doing, you've made a mistake.
Yes.
That exactly.
This is something Sergey has pointed out to me in several RFCs, where you do have state diagrams in there that explain to you how this protocol works, but then when you actually read the English text, there are other features that are explained but not shown in the state diagram.
I remember going through XML, like it was driving me crazy, some of these weird rules. and then I went through the logs of error reports at the beginning, and somebody had said, when I do this and this and this, it doesn't behave the way I want. So they almost verbatim took his message and said, when this happens, this should happen. And that became part of the definition. It was just bizarre.
Regardless, and when it has machines, you know, when it has, you know, machine-readable definitions, or at least formal language definitions in a specification, and English, and there's a conflict, the machine-readable stuff should always be normative and not be English.
Agree.
The English is informally to explain things to human beings.
Yeah, like if you screwed up and you explained it correctly in the English but incorrectly in the formal notation, too bad, you get to revise it. That's why there's a comment period.
Oh.
Do you think it's likely this will occur?
We just started talking about this today, so I don't know.
Well, no, it makes so much sense. I mean, if the spec isn't well defined, how you expect anything to come out of it?
But I mean, that's what happens in the wild.
I know, I agree.
Yeah.
So yeah, it seems like that's a great place to start. Keep the spec defined correctly.
And I think a lot of it comes down to the fact that these specs are designed by committee who want to stuff as many features in there as possible, and nobody who's implementing these actually wants all those features. So, if for something like DMP3, everyone implements a subset.
Well, there's a lot of standards bodies out there too, right? I mean, like, you know, we can go talk to the IETF, and my feel for that is, like, I think they'll probably, like, be receptive.
They'll probably be receptive.
But,
Yeah.
like, IEEE, that's a standards body too. ITU, that's a standards body.
Actually, it means like some LangSec people in every committee, because going to the IETF and saying you should do that kind of thing and actually implementing that in process, it needs active participation, I guess.
Which means, like, going and packing committees, which always feels kind of like sketchy to me, but, like, I guess we gotta.
It also means actually, you know, traveling to wherever IETF is 3 times a year. Because if you want to have influence there, you have to be, the FaceTime is very important. You need to press the flesh in the bar, or people do not pay attention to you.
One of the things that might help us get momentum on this is that one of the CWEs that we're trying to propose in that prior work that was mentioned is incomplete or incorrect specification.
That's true.
So if we can
Get MITRE to pick that up.
in getting MITRE to take that up and find the appropriate examples and mappings and reasons why it is like literally nothing else and all the other things that they demand that be filled in, snippets of compliant versus non-compliant code, etc., that will take approximately a year to get together. It might be a very easy sell to the standards committee to say, you know, please help people avoid the CWE.
Yeah, I mean, that applies to every standards body. All right, so I guess we're pretty much done for this year. Thank you all very much for coming. This has been a really fantastic workshop.
Yeah.
I mean, the papers were like a cut above this year. This was really, really great work.
A round of applause for the authors. And for the remaining audience. If it were
Yes.
not for you, we would have no workshop.
Thank you also to our sponsors, WideOps and ERNW GmbH.
And the previous sponsors who helped us get off the ground. And thank you for coming.